Welcome to class project 1. The name of the class project is optimize a simple function using gradient descent in Python. Now, with this class project, I have attached in what tools you're going to require to complete it and get a functional outcome. And also, I have created this class or this class project in such a way so you can follow up 5 simple steps, and also you will know by the end of this class what you're going to learn. So first off, let's get into what tools we're going to need in this class. The first thing that you're going to need is an IDE. Now I have put in, or I'm going to work with PyCharm because that is integrated for Python. But if you want to use VS Code or any other IDE that you're comfortable with and which supports Python, I would suggest you can use it. The next thing that you're going to need is Python 3. Now I'm also going to specify a version which is Python 3.12. Now anything before that version is going to be okay too. But before that version, what happens is that it cannot support the newer infrastructures of the code. Now, even if you have Python 3 or 3.12 and anything above like 3.13 or maybe 3.14, that is completely fine. Now, the libraries or the module that you need to use in this class project is going to be NumPy to handle your data. Then we're going to use matplotlib, which is basically going to help you to visualize your data. And the third optional library that you can use to derivate your verification and your data, or let's say your variable, you can use SymPy. So let's get into these steps. The first step that you need to do is create the project and the file. In step 2, you're going to define the function with the derivative. In step 3, you're going to implement the gradient descent. In step 4, you're going to visualize the optimization movement and you're going to save up the file. Step 5 is completely optional. You can write a short summary file if you want to, but if you don't want to, it's also completely fine. The last thing that you want to do, or that I would suggest you to do, is take a screenshot of your code snippet and also take a screenshot of your, let's say, the image that you're going to create or represent visually by using matplotlib. The outcome of this class project is that you will know how to create a functional gradient descent Python program. You will know how to illustrate the optimal path. You will also get the knowledge of derivatives and also gradients, and you will know how to use a function's value, which is decreased by gradient descent, and also a tidy project folder with well-organized files. So, first off, let's open up PyCharm and let's create our project. So, as we have opened up PyCharm, create a new project. Let's say the name is going to be class project 1. Inherit the package, make available to all project, create a custom environment, and press on create. In just a couple of seconds, you will see the project will be created. Now, as we have the project, we're not going to need any, let's say, out data, or let's say anything to download, because you are going to define the function, the derivatives, you're going to visualize the data, everything starting from the code snippet. So let's create a Python file. Let's say the data that I'm going to use, or the Python file, I'm going to name it test, okay? So, as you're not going to be needing any type of data, such as CSV or Excel, or even JSON, so you're going to start off directly from ground zero. Now open up the terminal and let's first off import the modules. Type in pip install and type in first off NumPy. Hit on enter and now wait for a bit until NumPy has been correctly installed on your device. Now, up till now, I have been installing NumPy on almost all of my projects, so it is not going to need any internet connection, because everything that needs to make NumPy function properly, every data is already available on my device. Now, let's also install Matplotlib. Hit on enter and wait for a bit until everything has been installed. And in a couple of seconds, you will see everything will be installed, like just in a couple of seconds. After that will be done, first off, let's import our first module, which is going to be, let's say, import numpy as np. Then I'm going to import matplotlib.pyplot as plt. Now, just like our second step, we're going to define the function, including the derivatives. So, the function, you have to define it with def. Now, as I want a function, now I'm going to apply the derivatives, which is x to be the variable. Now, here, I'm going to return it with the exponent of that value. So return it x double asterisk, let's say 2. I'm just going to keep it very simple. That is the function. If you want to apply the derivative, type in def, then put in df as the data frame, define the variable, and also in the same way, just get the derivative, which is return and 2 asterisk x. So that is going to be our function and also our derivative. Okay, now let's move on to the next step, which is the third step, which is implementing the gradient descent. Now, implementing gradient descent requires hyperparameters, such as your starting lead or the starting data. Then you're going to learn about, how fast your learning model can cope up with the data or how fast it can learn. And then you're also going to mention how many times you want it to iterate. Okay? So let's say it's kind of like how many times do you want the program to run. So first thing is my x. X is going to be equal, let's say 4.0. That is going to be my starting lead, or let's say my starting point. Now I'm going to define how fast or in how many steps my machine learning model can take the data. Let's say learning rate is going to be equal, let's say 0.2. So in every 0.2, or let's say this is the amount of data it can take. Now I'm going to define how many times do I want it to iterate. So I'm going to put in ITR. That's it. ITR is going to be equal to, let's say, 21. So I want it to work for 21 times. Now I'm going to define, let's say, the history of the data. So I'm going to put in history. It's going to be equal. Now, as we don't have any specific type of data, so I'm going to use the variable as x. Now, we're going to put in the loop because we want the program to run 21 times. So for I in range. Now define how many times. So here I'm going to define ITR. Okay, so iterated amount of, let's say, approach. First thing, as you want a gradient, so I'm going to put in grad. It's going to be equal to df. Now the variable is x. X is going to be equal to x minus, I'm going to put in the learning rate, and now I want to multiply it with the gradient. After that, you also want to append the history of the data. So I'm going to put in history dot append. Now the variable is x, so put in x. Now I want to print out the data. Let's say now I want to get the amount of iterated data. So f, let's say I'm going to put in iterated. So open up the third bracket just one time and put in I plus, now how many times you want to iterate or how do you want it to iterate is only one per approach. After that, put in a colon. X is going to be equal, third bracket, here x colon, and now I'm going to, let's say, put in 0.5. There we go, f, which is the function, comma. Now f is going to be opened up in the parentheses with the variable, and it is going to be equal to third bracket. Now put in f, open parentheses, as x, after the x, colon, comma, or let's say 0.5f. There we go. That is all that you need to put over here. So this is basically going to show you how close your variable is going to be closer to the minimum of data. If you run the program, this is exactly how it will look like. Okay, but you won't understand anything because it is basically just iterating over and over again. But it is based on the data and the history that you have put in. Now, the last and the most important step of this class project is visualizing your data and visualizing every data that we have over here, and also to check how the relationship between the data is. So, first off, we want to define the data with variables. First off, if you've seen my last class of this course, you know that for preparing the data model or the machine learning model, you need two variables. So, in that case, x1. You can put in xs if you want to, but I'm going to put in x1 is going to be equal np dot linspace. There we go. So I'm going to start off with -5 value. Then I'm going to put in 5 value. And also, what I want to do is I want to show them how many times do I want this program to run. So I want it to run 500 times. Now, I'm going to put in y1 is going to be equal to the function, and the variable is still x1. Okay, now we're going to define everything with the plot. plt dot plot. Now open it up with x1 as the first or the starting point. Then I'm going to put in y1 as the argument, and also we want a specific label. So the label that we're going to use over here, first off, put in equal. Now after equal, what you want to do is, even though we have the parentheses, single quotation, after that put in f, open parentheses, and then put in equal x, now to the power of, let's say we have exponent 2, so I'm going to put in 2 over here. Okay, now the next thing that I'm going to do is I'm going to put in plt dot scatter plot. Okay, so you can just put in just scatter if you want to. Now we want to validate the history, so type in history of the data, secondary bracket, f, open parentheses, as h for h in history. Okay, now put in comma. I'm going to put in the marker equal as o. Now after o, I'm going to put in a label equal, single quotation again. Let's say this is where we want to define where or which path is it going to take. So I'm going to put in gradient path. That's it. Okay, after this, what I'm going to do is I'm going to put in plt dot title. Now another thing that you can do over here is you can define the descent path, which can make it look a bit more better. But even though this is just a label, so I'm just going to put in descent path. Okay, this is exactly how it is going to look like. Now I'm going to put in the title. Let's say class project 1 gradient descent. That is exactly going to be the title. Now let's put in the x label and y label. plt dot x label. Let's say on the x label we want the variable which is x, and plt dot y label, open up the parentheses, double quotation, f, open parentheses, inside put in x, which is the variable. Okay, now PLT. Now one thing different that I want over here is I want legends. So PLT dot legend, open parentheses, PLT dot grid. Now open the parentheses and type in crew. And I'm going to save up the file plt dot save figure. Now you're going to put in a name. Let's say I'm going to put in, let's say, gradient dot png in this case. Now I'm just going to put in plt dot show. That's going to be it for this class project. Now you can run the program. When you run the program, this is exactly how it is going to look like. There we go. We have the data like this, but it is the opposite. You can create your, figure however you want to. That's basically up to you. Now the dot trial that you can see is basically indicating your optimization and your intuition. Okay? So this is exactly how your outcome is going to look like. And now you know how to create or how you can work with gradient descent on your project, or let's say even on your work. So thank you for watching this class project up to the very end. And the last thing that you want to do is take a screenshot of this alongside your code snippet and upload it onto our project panel so that we can check however you are progressing with work. So let's move on to class project 2.